So we have this question that a balloon is moving up vertically upward with constant acceleration g upon 2 in the upward direction. Particle A was dropped from the balloon, and 2 seconds later, another particle B was dropped from the same balloon. Assume that the motion of the balloon remains unaffected. Find the separation distance between the particle A and particle B 6 seconds after dropping the particle B. None of the particle reaches ground during the time interval under consideration. Right. So in this question, the balloon is given that's moving upward with the constant acceleration g upon 2. So if it's moving upward with the constant acceleration g upon 2, it means that it's going to maintain a constant increase in the velocity in upward direction. Right? That's how the constant acceleration is going to be constant. So here we will take the upward direction as negative and the downward direction as positive as per our sign conventions. So now we will trace the motion of the particle A and particle B. At first, let's suppose at time t. Let us suppose at time t, particle A was dropped. Particle A was dropped from the balloon. So the time under consideration is t. So at time t, what's going to happen? There will be some velocity, upward velocity of the balloon. Let's keep that u. And when the particle A was dropped from the balloon, it will have the same velocity as that of the balloon. That's going to be u, and it's going to fall under the acceleration due to gravity. That's t. Okay, this is the thing that's going to happen at time equals to t. But what's going to happen in 2 seconds? At time t equals to 2 seconds. In those 2 seconds, the balloon will travel in the upward direction and the particle A is going to fall in the downward direction. So there will be this separation between the balloon and the particle. In those 2 seconds, there's going to be the separation between the two. So how much has the balloon and the particle A separated in 2 seconds? We will first figure out that. Then we will see that at the time t equals to 2 seconds, the particle B was also dropped. Don't forget that. So what's the separation between A and B? We know that the balloon is going upwards and the particle A is going downwards. So they are having the relative motion with respect to each other. We will keep particle A in rest and we will give its velocity and acceleration to the balloon. So it's in the opposite direction. If the velocity of particle A is in the u in the upward direction, once given to the balloon, the velocity is going to come in the downward direction, and the acceleration of particle A is in the downward direction. So the acceleration of balloon is going to come in the upward direction g. Okay, so acceleration of balloon with respect to particle A comes out to be g plus g upon 2, and that's going to be 3g by 2. And velocity of balloon with respect to particle A comes out to be u minus u, and that's going to be 0. So the separation, we will use the second equation of motion. Separation of balloon with respect to particle A in 2 seconds is going to be, first term is going to be 0. Half of, what's the acceleration? 3g upon 2 multiplied by the time under consideration is 2 seconds. So it will be 2 squared. This 2 squared and the bottom 4 is going to get cancelled. So the separation of balloon with respect to particle A in 2 seconds comes out to be 3g. Right? So let's take the next slide. So we will say that I will say that in 2 seconds the particle A and the balloon has separated by a distance equal to 3g. So we will say that in 2 seconds the particle B has reached somewhere here. Particle A, this particle A, and the distance between the two, separation distance, is 3g when the time was 2 seconds. At this time the particle B was dropped. At this time the particle B was dropped from the balloon. The particle B was dropped from the balloon at time t equals to 2 seconds. So in those 2 seconds the velocity of A has changed, the velocity of balloon has changed as well. So first we need to figure out what's the velocity of balloon at time t equals to 2 seconds. It's going to be upward. Let's keep that VB. We need to find out what's going to be VB in time t equals to 2 seconds. So VB is going to be, its initial velocity was u in the upward direction. Since the upward direction is negative, I will take it minus u, plus its acceleration was upward direction g by 2, so it will be negative, multiplied by t equals to 2. So the velocity of balloon after time equals to 2 seconds is going to be minus u minus g. And what's going to be the velocity of particle A at time t equals to 2 seconds? It's going to be downwards. VA is going to come out to be, what's its initial velocity? It's minus u, plus its acceleration is downwards, and 2g. This is going to be the velocity of A at t equals to 2 seconds. So at time t equals 2 seconds, the velocity of balloon is minus u minus g. And at the same time, we are dropping the particle B. So the particle B is going to have the same velocity as that of the velocity of the balloon at time t equals to 2 seconds. So velocity of the particle B is going to be minus u minus g. Now, already the particle A and particle B are separated by the distance 3g at time t equals to 2 seconds. Now, what's going to be the further separation for time for 6 seconds? How much they are going to separate now for 6 seconds? Again, they are in the relative motion. So what we are going to do, we are going to keep the particle B in rest, and we are going to give its velocity and acceleration to the particle A in the opposite direction. So now, keeping particle B at rest, we will take velocity of particle A with respect to particle B is going to come out to be, what's the velocity of particle A? It's minus u plus 2g, and it will be subtracted by the velocity of particle B since it's in the upward direction, minus u minus g. So the velocity of particle A with respect to particle B comes out to be minus u plus 2g plus u plus g. Minus u and plus u gets cancelled out. So the velocity of particle A, relative velocity of particle A with respect to particle B comes out to be 3g. And what's the relative acceleration? Relative acceleration of particle A with respect to particle B comes out to be 0. G in the upward direction and g in the downward direction. So the total is going to get cancelled out. Now we will use the formula. Separation of particle A with respect to particle B in those 6 seconds comes out to be UAB multiplied by T, and the second part of the equation is going to come out to be 0 because the acceleration is 0. So the separation of particle A with respect to particle B is going to be given by UAB is given by 3g, and we are tracing the separation in 6 seconds. So the separation of particle A with respect to particle B comes out to be 18 times g. What's the total separation? Total separation. Total separation. You need to focus on one thing. Particle A was dropped, okay, and in time t equals to 2 seconds, the separation of balloon with respect to particle A was 3g. After time t equals to 2 seconds, particle B was dropped, and in those 6 seconds, the particle A and particle B that were already separated by 3g distance are separated by the distance equals to 18g. So what comes out to be the total separation? Total separation will be equal to 18g plus the initial separation that was 3g, that's coming out to be 21g. So g equals to 10 meter per second square, that's 21 into g, which is equal to 21 into 10 meter per second square, or it's going to be 210 meters. Thank you.